Hi there, in this video we are going to go over how to solve system of equations by graphing. So first thing you need to know is what a system of equations is, and that is a set of equations that have the same solution, or solutions, right? We're talking about x comma y. All right, so your steps that you need to know. Step 1, you have to change it into y equals mx plus b form if necessary. Step 2, you want to graph the two lines using the slope and the y-intercept. Step 3, you want to find the point where the two lines intersect. And then step 4, you want to plug in that ordered pair into both equations and see if that's the correct solution. So let's look at that example. Let's look at our first example here. We have y equals x and y equals negative 3x plus 4. So the first line I'm going to graph is this one here. And, oops. So the first graph I'm going to graph is this one here, and it's y equals x. So I know that this equation is actually y equals 1x plus 0, where our slope is 1 and our y-intercept is 0. So I'm going to start with my start with my y-intercept, my b equals 0, and then I'm going to go up 1 and right 1. Hopefully you remember that when you have 1 over 1, it's 1 up and 1 right. So up 1, right 1, up 1, right 1, up 1, right 1, and then you just continue doing that. It's also the same as down 1, left 1. All right, so down 1, left 1, down 1, left 1, down 1, left 1. Okay, so that is the first line. Okay, the next line, which I'm going to graph in blue, we know that the slope is negative 3 and the y-intercept is 4. So here is where we're going to start at the y-intercept. And then negative 3 means negative 3 over 1, which negative 3 means down, and then 1 means right. So we're going down 3, right 1. So 1, 2, 3 down, right 1. 1, 2, 3 down, right 1. So, okay. And now we have to find the point of intersection. So the point of intersection is right here at 1, 1. So your answer is 1, 1. All right, and now we can go ahead and plug that in and see, does that work? So if I take this first equation here, y equals x, and I plug in y for 1 and x for 1, that does check out. If I do the same thing down here for this next one, y equals negative 3x plus 4, right? If I plug in 1 for x and 1 for y, let's see. Do I get the right answer? So negative 3 times 1 is negative 3, plus 4 does in fact get me 1. So that's just a quick way to check. Once you find your point of intersection, that is your solution. All right. Next, we have y equals x plus 2 and y equals 2x, y plus 2x equals 4. All right, so the first one is pretty straightforward because it's already written in slope-intercept form, which works in our favor. So that's what we want. We want y equals mx plus b because we need to know what our m is and we need to know what our b is. So m in this case is 1, right? Y equals mx plus b. So m is 1 and b is 2. So our first graph, which I'm going to do in orange, is we're going to start at b equals 2. So the y-intercept is 2. And then we're going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, down 1, left 1, down 1, left 1, down 1, left 1. All right, so that is your first line. Okay, the next line, we're going to have to do a little bit of extra work here because it's not written in slope-intercept form. It's not written in y equals mx plus b form. So what we're going to have to do is we're going to have to change this so that it is in that form. So we are going to start first with subtracting 2x on both sides, and then we have y equals negative 2x minus 4. So now that it's written in y equals mx plus b form, we can identify our slope and our y-intercept. So our slope here is negative 2 over 1, and our y-intercept is negative 4. So we're going to start at the negative 4, and then we are going to go down to right 1, down to right 1. It's the same thing as going up to left 1, up to left 1, up to left 1. Okay, and sorry, that did not cross over well. So our point of intersection here is right there at -2, 0. All right, now if we take these two equations and we plug in the x and y, we should get the x and y values that are given in the original problems. So let's test that and make sure. So we've got here y equals x plus 2. If we plug in 0 for y and -2 for x, that is correct. We do end up getting 0. Okay, and then for our next equation, which I'm going to put right here, we have y equals y plus 2x equals -4. We plug in 0 for y and -2 for x, and sure enough, this does equal -4. So both of those check out. All right. Moving on, we have y equals x minus 2 and x plus 3y equals 6. So this first equation is, we have our slope as 1, so 1 over 1, and then our y-intercept as -2. So we start here at -2, then we go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1 for each. You can also go down 1, left 1, down 1, left 1, down 1, left 1. All right, so that was the first one. For the second one, we have to turn this into slope-intercept form, so we're going to have to subtract x on both sides, which leads us to 3y equals -x plus 6. And we're going to divide 3 on all sides, and we get y equals -1/3 x plus 2. In case you're confused where I got the 1 from, it is right there in front of the x, even though we don't write it. All right, so now we put in our slope, or identify our slope, which is -1/3, and identify our y-intercept, which is 2. So we're going to start at 2, and we're going to go down 1, right 3. Down 1, right 3. All right, so there is our second line, and then our point of intersection is right over here. That point is at 3, 1. Okay, and now if you plug in that solution into your two equations, you should get, both equations should work out. So if I were to solve this down here, y equals x minus 2. If I plug in 1 for y and x for 3, or 3 for x, I should say, 3 minus 2 does get me 1. If I were to plug in this next one, right, so x plus 3y equals 6. If I plug in x to be 3, y to be 1, I do in fact get 6. So that is the solution for that problem. All right, moving on. So far, we have been working with lines that have been intersecting, so therefore they have one solution. Okay, not everything will have one solution. If you have two lines that don't intersect, so they're parallel, then you will have no solutions because they'll never intersect. Also, if you have the same line, so you're being asked to graph the same line twice, then you have infinitely many solutions. So let's look at a couple of those examples. For this first one, we have y equals -x plus 1. So if we have a -1 here, our slope is really -1 over 1, and our y-intercept is 1. So we're going to start at the 1, and then we're going to go down 1, right 1, down 1, right 1, down 1, right 1, up 1, left 1, up 1, left 1, up 1, left 1. So that is our first line. Okay, and then next, if we plug in the 1 there, we have m equals -1 over 1, and b equals -3. So here is -3. Now we're going down 1, right 1, down 1, right 1, down 1, right 1, up 1, left 1, up 1, left 1, up 1, left 1. All right, so you will notice that these two lines are parallel. So since they are parallel, then this would be no solution. Okay, let me give you a little hint. If you have two equations with the same slope and different y-intercepts, the lines will be parallel, and thus you will have a no solution system. All right, the next example is y equals 2x plus 4 and y minus 2x equals 4. So we're going to start with the first one. So this is easy to identify our slope. So m is 2 and then our y-intercept is 4. So we'll start here at the 4 and then we're going to go up 2, right 1, up 2, right 1, up 2, right 1, down 2, left 1, down 2, left 1, down 2, left 1. All right, so that is our first line. And then for the next one, we do have to turn that into y equals mx plus b, or slope-intercept form. So we have to add 2x to both sides. So then we have y equals 2x plus 4. So our m is 2 and our b is 4. So we're going to start at the y-intercept of 4. Then we're going to go up 2, right 1, up 2, right 1. So you notice that this is already the same line. So therefore, this would be infinite solutions. All right, so that's all. Hopefully you learned how to solve a system of equations by graphing. Thank you.